Good evening all. Good evening. You are welcome to Tutorials with Fermentanti the Schoolboy. Today we'll take a look at chemistry. Chemistry, and the topic for today is separation of mixtures and purification of chemical substances. Separation of mixtures and the purification of what? Chemical substances. That's the topic. There are about up to 5 subtopics under this topic. So the main topic is what? Separation of what? Mixtures and the purification of what? Chemical substances. So under these subtopics, under this topic, we have different subtopics. But before we go into that, I want you to take down this assignment. It's already on the board. I'll just call it out. But after class, you can complete it if you have not completed it. You do the assignment. In our next class, which is on Monday, we'll review this assignment. Please ensure you study it. Study the topic and solve the question. Don't just go and look for the answer and tell me C. No, I won't take it. Are we together? So ensure you solve this thing and then do it well. So the question 1 says, the presence of impurities in a solid will make the melting point to A, decrease, B, increase, C, remain unchanged, D, be what? 0. Number 2, the normal boiling point of a liquid is defined as the temperature A at which its vapor pressure equals the atmospheric pressure, B at which bubbles begin to form, C at which the vapor pressure equals 1 atmosphere, D at which the rate of condensation of vapors equals the rate of vaporization of the what? Liquid. Number 3, in an experiment, which of the following observations would suggest that a solid sample is a mixture? A, solid can be grounded to a fine powder. B, the density of the solid is 2.25 grams per dm3. C, solid begins to melt at 573 Kelvin, but is not completely melted until 648 Kelvin. D, solid melts at 300 Kelvin. Number 4, a process that involves a physical change is A, burning of butane gas, B, exposing sodium metal to air, C, subliming sodium hydroxide in water, D, dissolving sodium hydroxide, C, subliming sulfur. Let me repeat number 4, please. A process that involves a physical change is A, burning of butane gas, B, exposing sodium metal to air, C, subliming sulfur in hot air, D, dissolving sodium hydroxide in water. Number 5, by means of filtration, one component can be obtained. This place should be obtained. Please correct it. Obtain. By means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride and A, potassium nitrate, B, sand, C, lead nitrate, D, sugar. Please, these assignments we will review in our next class. Now let's continue our lecture. Okay, so I say that the topic is separation of mixtures and purification of what? Chemical substances. Then under this topic, we have about 5 subtopics we look at. Subtopic 1 is pure and impure substances. Pure and impure substances. Pure and impure. What are you writing? I'm talking about what else. You're busy writing this. Huh? We have left you since you are still writing that thing. Go to what we are doing now. I said that the topic for today's class is separation of mixtures and the purification of what? Chemical substances. And I said that we have about 5 subtopics under this topic. And these subtopics are as follows. Number 1, pure and impure substances. Pure and impure substances. The topic is what? Do I need to write it on the board? No need, right? Where are you? Chibuzo is not fast writer. He's always lagging behind. I don't know why. Where are you now, Chibuzo? Tell me where you are. Chemistry. Okay. Separation of mixtures and purification of chemical substances. You don't hear? Separation of mixtures and the purification of chemical substances. So we have the following subtopics under this topic. Number 1 is what? Pure and impure substances. Number 2 is boiling and melting points. Number 2 is boiling and melting points. Number 3, elements, compounds, and mixtures. We have done this, right? We have done this in this class. But I just want to add it there so that you know what you expect to know under this topic. Elements, compounds, and what? Mixtures. Number 4, chemical and physical changes. Have you done that one? Good. Chemical and physical what? Changes. Number 5, separation processes / techniques. Separation processes / techniques. Separation processes / techniques. So under separation processes / techniques, we look at the following techniques. We look at the following techniques. We call them separation processes or separation what? Techniques. Under the separation techniques, we look at the following separation techniques. Number 1, evaporation. We look at evaporation. Evaporation. After evaporation, we look at simple and fractional distillation. We look at simple distillation. We also look at fractional distillation. You know that simple distillation and fractional distillation are not the same. I hope you know. Good. We look at simple distillation. We also look at fractional distillation. We look at sublimation. We look at sublimation. We look at filtration. We look at crystallization. Of course, you know that under crystallization, we also have simple and fractional crystallization. Hope you know. Are you aware? Under the same way we have under distillation. Under distillation, we have simple and what? Fractional distillation. The same way under crystallization, we have what? Simple and what? Fractional crystallization. We look at 2 of them. Simple crystallization, fractional crystallization. Then we also look at chromatography. Under chromatography, we look at paper chromatography, column chromatography mainly. Even though we have gas chromatography, but we focus on, we have gas chromatography, paper chromatography. We also have column chromatography. But we focus our attention on what? Pepper and what? Column what? Chromatography. Who have heard about that before? Who? Raise your hand if you have. If you heard about chromatography, raise your hand. Let me see. Who have heard about chromatography? Let me. Don't worry. I want to ask you. Just raise your hand. Who? Okay. Only one person. I said I will not ask question. Just raise your hand for the first time. Have you heard about chromatography? Only one person. 2 people. Are you serious? Even in your school. You didn't do it in your school. You uncle? Huh? You swear. Now, then we have magnetization. Then finally we look at decantation. Finally we look at what? Decantation. If I were you, these things are listed. I'm giving you a guidance on how to study. If I were you, I just go now to my textbooks and start studying these topics I broke down. If I were you, that's what I would do. Any question? Good. Certification is also there. I like that. It's also there. Certification is also there. I'm just focusing on what is in the what syllabus. Okay. This I'm calling now is what is in JAM syllabus. But we look at it. There's nothing wrong with it. Okay. I just focus on what you have, what I see in your what JAM syllabus. That's what I'm doing. And when I told you I'm following your syllabus, one letter to what letter. But I'll mention it while we are discussing that. I'll just talk about it. Okay. But those ones are listed are the ones in your what JAM syllabus. Okay. Now, let's now go down to the business. The first subtopic we look at is what? Pure and impure substances. Pure and what? So basically, our topic for today is what? Pure and what? And what? Impure what? Substances. At the end of, put down, objective of this topic, put down the objective, what we intend to achieve at the end of this topic. The objective is that at the end of this topic, the students should be able to distinguish between pure and impure substances. This is the objective of this topic. At the end of this topic, you should be able to do what? Distinguish what? Pure and what? Between pure and what? Impure substances. If at the end of this class, by the time we enter a new topic, if you cannot distinguish between pure and impure substances, you learned nothing from this what topic. So this is what you focus on. You should be able to say that this substance is pure, and reasons why it's pure. That this one is what? Impure, and the reason why is what? Not is what? Impure. Now let's go down to the business. Have you putting down the objective of this topic? Now, let me explain in chemistry now. If you hear that something is pure, what comes to your mind? Who can define a pure substance for me? What comes to your mind? Let me know what you know about pure substance. Each time if you hear the word or the phrase pure substance, what comes to your mind? Gina, yeah? Tell us.
What comes to my mind is that maybe when you say that something is pure, maybe the thing is free from impurities or any form of contamination, or like it's made up of one particular element, like more a mixture or more combination with any compound or something like that.
Do you agree with her? They don't hear you, Tina. Speak out.
My own understanding it means like when something or any combination or mixture, just one something, one substance. in that when something is in its original form, moral combination, or anything combined with it, or do like in its natural form without no free from impurities or any other combination or contamination with another element or substance.
Do you agree with that? You say yes. Chinwendo, do you agree with that? Huh? Huh? Sit up. You are in classroom. You do agree with her? You don't know if you agree with her. Comes, do you agree with her? Sit up, please. Do you agree with her? Comes, do you agree with her? You don't know. Huh? It doesn't matter. Do you agree with her? This is just simple layman understanding. She's sharing layman understanding. She said that something is pure, is impure. If it is as it is, there's no, it's not combined with any other word thing. Is what? Pure. That was. Do you agree with her? Huh? Do you agree with her? Did you even hear what she said? So do you agree with her? Full substance. What I say? Now listen. Jesus, look up, please. Now listen, there's something I want you to know. If I get Gary now, Gary grains now, Gary, you know Gary now, the one you make and eat. If I get it now, and there is nothing else in that, if I use a cup to get the Gary, and there is nothing else in that Gary, no sand, nothing else in that sand is what? Pure. Am I communicating? As far as chemistry is concerned, is what? Pure. Now, but maybe if there's sand or any other thing that is not Gary in that cup, that thing becomes an what? Impurity. Are you with me? That thing that is in that, if it is sand, whether it's sand though, or whether it's ochre, maize grain that is in that sand, and that is in that what? Hello? That is in that what? Gary. That maize becomes an impurity. Are you aware? Are you aware? If what you want is Gary, the maize becomes what? The grain, the maize grain becomes what? Or the beans grain becomes what? An impurity. Now, if you have a cup that contains both Gary and beans, what you desire, you need is what? Gary. The beans becomes what? An impurity. But if what you need is what? Beans, the Gary becomes what? An impurity. So that combination of Gary and beans, if one of them is what you want, the other becomes what? An impurity. So that mixture, that Gary and the beans in one cup is a mixture. It got two different things and mixed together. All together, it becomes a what? A mixture. So a mixture is an impure substance. Are we together? A mixture is an impure substance. Let me use salt. If you get salt now, let me ask a question. If you get salt, if you collect salt with your spoon, with a tablespoon, and what is in that spoon is only salt. Is it pure? Is it pure or impure or impure? It's pure, right? Now, if you add that salt in water, is it pure or impure?
Solution.
Huh?
to form a solution is impure.
Is that what?
Sir, I said it to form a solution is impure now because of combination of salt and water.
She said it's impure. Is it pure or impure? It's pure. Why do you say it's pure? What? The salt dissolves in water. So that's why it's pure. Is it pure or impure? Which one? Is it pure or impure? You can't go. Okay, you don't know. What's going on here? Huh? These are things you should know now. Or have you blocked off? Don't switch off in class. It's not good. This is an interactive class, okay? Don't switch off in class. It's not a good thing. This is time to wait to ransack your brain. Try to find out, think it out. Think out of the box. It's not the time to stay and say, I don't know. No. That's wrong attitude. It's not a good attitude to class. Counsel, what do you think? I'm asking what you think. You are saying you don't know. Which one you don't know? It's not good. What do you think? It's impure. What do you say is impure? It has mixed with water. Good. You. What do you think? Is it pure or impure? Impure. Why? You say what? Good. I like that. So it's an impure. You come. What do you say is an impure? Now remember when we discuss mixture, we say a mixture contains two or more what? Substances that are, but they are not chemically what? Combined. Are we together? They are together, but they are not chemically what? Combined. You read it? Have you read it in your chemistry textbook? Have you read it? Please keep reading, okay? Before what's going on, you become part of it, okay? Just read. Open it, read it. Whether you understand it or not, keep reading. By the time you come to class, you understand it. Okay? Good. Now, the mixture is what? A mixture is an impure substance. So far that solution is concerned, is an impure substance. I like your reasoning. You said that the salt dissolves in the water, therefore it's a pure substance. Now let me tell you why it's not a pure substance. It's not a pure substance. Even though the salt dissolves in the water, it's not a pure substance. It's a mixture of what? Water and what? Salt, which is sodium chloride. Salt is what? Sodium what? Chloride. It's a mixture of what? Water and salt. It's a mixture, but it's a type of mixture. What type of mixture is that? It's a solution, I know. What type of mixture is solution? And what? Yes, but it has a name. That solution form, what type of? We agree. You agree with me that now that sodium chloride and water will form a mixture. You agree with me, right? And that mixture is a solution. What type of mixture is a solution? We discuss it in this class. We even answer questions on it. We review assignment on it. So what's going on here? What type of mixture is sodium chloride and water? Sit up. What type of mixture is that? No. We have done mixture in this class and we have answered questions. Even did that name, we mentioned it and answered question in it. So what's going on? That will answer your question. Homogeneous mixture there is a homogeneous what? Mixture. Do you now agree with me that thing where sodium chloride is dissolved in water, it forms a solution. Solution is not a pure substance. A solution is a homogeneous mixture. A solution contains a solute dissolved in what? Solvent. Both the solutes and the solvent are different what? Substances. They come together to form a solution. So it's not pure. is an impure substance. True or false? True or false? Good. But if you get only sodium chloride alone, sodium chloride is a pure substance. Is it clear? Is it clear? Sodium chloride is a what? A pure substance. If you get an element, a metal, iron on its own is a pure substance. But when it forms an alloy, did we talk about alloy in this class? Alloy, we mentioned alloy in this class. We mentioned what? Alloy in this class. Alloy, spell, what is spell of alloy? A what? A what? A what? Double what? L-O-Y. Alloy. So when an alloy contains one or two metal, right? Combined together, right? Good. You can see copper. Give me an example of alloy with results in this class. Bronze contains what and what? Copper and what? Now look at these two elements now. Copper, two of them are elements. They are metals, right? Are they metals? Is still a metal? Let's just say element. When they combine to form a bronze is an impure substance. A bronze is what? An impure substance because it contains what? Two elements. True of us? True of us? They are not what? Bronze is not pure. So an alloy is an impure substance. So with this now, if you are asked now to talk about what's a pure substance, can you explain it? A pure substance is a substance that exists on its own in its original form without combining with any other word substance. That is a pure substance. A compound is a pure substance. A compound is a pure substance. Do you know why? I should explain why a compound is a pure substance. Good. A compound contains elements that react and bonded chemically to form a new substance. That new substance is different from the component what? Element. It's pure. Water is a pure. Water without any form of impurity, nothing combined in that water, is a pure substance. Is water a compound or an element? Is water a compound or an element? Water is a compound, right? Because water is formed by what? When hydrogen, right? When hydrogen reacts with what? Oxygen. Water is what? I'm answering your question, Izu. When hydrogen reacts with oxygen, let's balance the equation. This is 2, this is 2, this is 2, this is 1. If you put 2 here, right? Are we together? And you do what? You put here. It's balanced, right? Now, when hydrogen, which is an element, even though it's diatomic, react with oxygen, which is what? An element, even though it's what? Diatonic. They will combine to form water. This water form is entirely different from what? These two things. This hydrogen and what? Oxygen. Water has it's entirely different. It's a new substance formed on its own. So water on its own is pure. Hydrogen is pure. Oxygen is pure. They combine and bond chemically to form what? Water, which is pure on its own. So a compound is a pure substance. If this water has no other thing inside it, it's a pure substance. So examples of pure substance, elements are pure substance. I have defined pure substances now. I'm giving substance examples. Onyesu is not writing anything. Chibuzo is not writing anything. Izuchukwu is not writing anything. Only females are writing. What's going on? Our males, what's going on with you? Only females are writing. Tomorrow you say we will not discuss pure substance. We will not discuss examples. I gave you the definition here now, right? And you did put it down. If you open your new school, you will not see the picture of a pure substance there. But by implication, if you read it by implication, you can deduce, you can get a definition, but it's not direct. That's why I gave it to you. From what I've been saying since, I coined a definition now. For what I've been explaining since, I have coined a definition, which I believe you can do. But I want to do it for you. I have coined a definition and give it, and I'm giving you some instances, examples. I say elements, they are pure substance. Metals, when you say element now, you have metals and non-metal, true or false. Then compounds are pure substance. You can give examples of elements. You can give examples of what? Compound. We are giving an example of compound, which is water. Water is a pure substance. But when water has sand, or the water has salt inside it, or the water has dust particles, is it still pure? It's no longer pure. It's now a mixture. Whether they dissolve in water or whether they don't dissolve. If they dissolve in water, they become a homogeneous mixture. True or false? True or false? Yes, are you with us? Are you sure? But if they don't dissolve in the water, it will become a what? A heterogeneous mixture. Is it clear? Good. Snake lime. Snake lime is a compound, it's not a mixture. Snake lime is a compound.
Is it an example of impure substance?
We say something now. If it's a compound, what is it?
It's a pure substance.
I've already told you here that a compound is a pure substance. You agree with me? You asked me about snake lime. I said that snake lime is a compound. What is snake lime? It's not calcium monoxide. It's a compound. That's why it's not a physical change. When water combined with calcium monoxide is quick lime. It's not a physical change. It's a chemical what? Change. A new substance, which is what? Look at it. As I think we have done this in this class. When calcium monoxide reacts with what? Water. You form what? Calcium what? Hydroxide, which is what? Slaked what? Lime. This thing is an entirely different compound. It's a compound different from these two things. So that means you can combine with another compound to form a what? Another what? Compound. And it's entirely different. Properties of calcium hydroxide is quite different from that of water and what? In our last assignment, is slaking of lime a physical change of chemical change? Huh? Are you sure? Are you sure? In emotion? Huh? No, forget what I say. I'm asking a question. Is it chemical or physical change? Huh? Is it? This will be lost. See? Are you lost? Are you following us? What is it? Now let me explain. You know, let's assume now, if you get salt and put it in water, small time, this little time, the salt will dissolve in the water, right? Can you still see that salt? You cannot see that salt. So because you cannot see that salt, the salt has blended in the water. You can't see the salt again. It will form a solution. That solution, you can even see through it. Is a homogeneous what? Homo, the same. It has formed a similar face, the same face. We call it face with the water. You cannot see that salt again. It's a homogeneous what? Mixture. But you understand what we mean by mixture, right? Now, but take the same salt, take sand, and put in water. What will happen? It will not dissolve. You can still see that sand in the water. True or false? It does, because it will not dissolve in that water. You can still see the sand. And you can even separate the sand. Are you there? Just simple separation. You separate the sand. Simple separation. Now, that mixture form is a what? Heterogeneous what? Mixture. The same thing if you get, let's look at liquid. We'll be talking about solid, liquid. Let's talk about liquid and what? Liquid. Get alcohol now. Get alcohol or ethanol. Kai. Put it in water. It will just blend. You will still see kai again. True of us. But you only do it while you know that it's there. If you smell it, if you get it go to your nose, that way you know that it's there. But get oil, even vegetable oil, and put in water. Can you see that vegetable oil? You can see it, right? It won't dissolve in the oil, in the water. That thing is a what? Heterogeneous what? Mixture. Is it clear now? Please, I don't understand. Please, I like my class. I like asking me questions. Don't you see now? The question she asked has led me to explain certain things. Don't keep quiet in my class. Even if you are up to 100 here, that is how I'm asking you one question. This is how I'm going to my class. I don't stand here in my class. I'm going from table to table. Everybody will do what? Participate. Ask questions. Don't keep quiet. That's how you learn. Okay? Please. Now, what's that? Any question? Now, that is what we mean by what? Pure substance. Of course, by implication, you can define an impure substance. True of us. An impure substance has what? Two or more combined or together, but not chemically combined though. Hello? An impure substance has two or more substance. An impure substance is a substance that has what? Two or more, that exists in combination with two or more what? Substances, but they are not what? Chemically what? Combined. Nyeso is not writing again. What's going on? Even you. Okay, do you listen to these things? To lectures? Yeah, that I post all these lectures there. If you listen to it, it's okay. You can listen to it. Okay? But still put down something while we teach, okay? It will help you. Maybe after the class, you can listen to the lectures and you use it to make up your words. As I define something, as I say something, you pause it and write it in your notes, play it again, get the information and put down your notes. With that, you make up your notes. But start now, don't wait till then. So an impure substance, something that exists with what? In combination with what? Other what? Substances. But they are not what? Chemically what? Combined. Now, because the impure substance, the constituent of the impure substance are not chemically what? Combined. They can be easily what? Separated. Okay? Because the constituent of the impure substance are not chemically combined, they can be easily what? Separated using simple physical, using simple what? Separation what? Techniques. They can be what? Separated. Because they are not chemically what? Combined. Remember our aim in this class, this topic is that by the end of this topic, you should know to distinguish between pure substance and what? Impure substance. So based on their definition alone, can you distinguish between pure and impure substance? Tell me one difference between pure and impure substance. Based on their definition. Combined. One, I agree that I agree with you. Pure substances are on their own. They are not combined with any other word substances. But an impure substance word can combine with other word substance. True of us. True. Is a one word difference between the two of them.
Impure substances are not chemically combined.
Good, I like that. What of pure?
Pure substances, not all pure substances are chemically
Not all of them. Which one are chemically combined?
combined.
Good, I like that. Please can you talk with him? He's thinking now. He's listening. Clap for him. Clap for him. Clap for him. I like that. The second difference is this. Pure substance, like example compounds, the components are chemically what? Combined. But impure substance, all the impure substances, they are not chemically what? Combined. True or false? True. That's second difference between the two of them. Who can tell me another difference between the two of them? From what we have discussed. I will tell you other difference from what we discussed so far. Can someone tell me the difference again? Any other difference we can deduce from this, from our discussion so far? Who can tell us another difference from what we have discussed so far?
Pure substance.
Uh-huh.
They can be easily separated.
What?
Easily separated.
Which one?
Pure.
Pew. Ah, see. Pew.
They cannot be easily separated. But impure, they can be easily separated.
Good. Now, let me put it well. The third one is still based on the one we have mentioned before. Now, the third one, you can say that component of pure substances like compound element is not inclusive. Hope you know. You know, as I said, that pure substance can be what? Compound element. Hope you know. I said that component of pure substance like compound, example compound cannot be separated by ordinary what? Physical what? Process. True or false? But constituents of impure substances can easily be what? Separated using physical what? Processes. Are we together? Good. Now let me add to this one. Maybe before we continue with the difference, I want to point out something. There's something I want to mention. There's something I want to mention. When you are done, let me know. I want to explain something first before after explaining it. After the explanation I want to give now. From that explanation, you tell me the differences again that you can see between pure and impure substance. Now listen to what I want to explain. You can put down if you can, but try to understand what I want to say now. Now listen. Now, when a substance is, this thing I'm telling you now will lead us to our next topic we'll discuss in our next class. It will lead us to boiling point and melt. In fact, let me just talk about it. No need, because we are not talking about much there. But I want to use it to distinguish between pure and impure substance. I want to tell you something. If a substance is pure, listen carefully. If a substance is pure, know this point. If a substance is pure, its melting point and boiling point is fixed. Difference. For a pure substance, the melting point and boiling point are fixed at a particular what? Temperature. The melting point and boiling point of a pure substance is fixed at a particular what? Fixed. F-I-X-E-D. Temperature. But the melting and boiling point of a mixture is not fixed. It's a range. It exists as a what? Range. The melting and boiling point, the temperature for melting and boiling of an impure substance is not fixed. It exists as a what? range. It starts from this temperature and stop at this temperature. Do you know why? Who can tell me why it exists as a range? I want to know someone that thinks fast here. Who can tell us why the temperature at which the what is it called? A pure substance boils or melts is fixed, while the temperature at which the impure substance boils or melts is a range? Who can tell me the reason why it's a range? Start from pure substance. Why?
Because it's pure. Like when it's pure.
Because it has no what? No substance is there. Continue now. I like what you say now, but continue. Any idea? Because of what? Because it's what? Okay, no, let's finish with pure first. Maybe after when we're done with pure, you will talk about impure. I will give the opportunity to talk about impure. Any idea on impure? Who has any other idea on impure? Chineye and Chimon, you tried, but it's not smooth. Do you have any idea? Now listen. For a pure substance, why the temperature at which the pure substance boils or melts is fixed at a particular temperature is because it's pure substance. There's no other substance there. And every substance has its own temperature at which it does what? Boil or what? Melt. Okay, depending whether it's a solid or a gas or a liquid, depending. Is it clear? Now, because there is only one substance there, there's no other combination. It's not combined with anything. Now, Onye also said that he want to tell us why that of impure substance exists as range. Tell us.
Okay, for impure substances, there are two substances.
Two or more.
Mixed with each other.
Okay.
For example, something like oil and water.
Okay.
Over time it will change. After pouring it,
okay.
Over time the oil will be on top and water will be on top.
Okay.
So when you're boiling it, it will take more time for one of them to boil than the other.
Okay.
If you start boiling it when it has not yet moved,
okay,
it will be a different boiling point.
Okay. Who else has anything to say there? Who else has anything to say? Okay.
This when there is like impure substance, because there is substance that is not chemically
combined. Okay.
It makes maybe the larger the impurities.
Okay.
Yeah, it will make it to increase the boiling point above 100 degrees.
Okay.
Or so and the melting point will be like faster.
You are trying, but you are asking something else. Now, okay, you are there, but let me explain. Hello, are we together? Now listen, let me explain something. Let me explain. Do you know that these substances that come together to form an impure substance, they are not chemically combined. What it means that they retain their individual properties. Are we together? I say that each substance has its own temperature at which it boils and melts, right? Now, let's assume you carry three of them, mix them together as a mixture. Three things that have different boiling point and melting point. They mix together as a mixture. You keep them as a mixture. Now, if you look at them, they will not boil. They will not boil or melt at a point. It will be a range. It will be a what? Range. It will start, maybe the one that will boil first will start boiling. Others there will also be what? Do at their own time. So the time for each of them to boil the boiling time, the boiling will become a range. It will start at a particular what temperature and stop at a particular what temperature that will accommodate the boiling point of all the what constituent substances. Am I making sense? Yes, am I making sense? So that's one difference between what and that. Is it the third or fourth? Fourth, right? Between what pure and what impure substances. Does it make sense? Does it make sense? Now, the last one for the day before we go, is that I want to explain something again after you tell me what you think. Now, if you get, remember I told you that every substance, they have their own time, their own temperature at which they boil or melt. Now, when a substance is pure, it will boil at that temperature it should boil, okay? And melt at that temperature it should melt. When a substance is pure, it melts at its melting point and boils at its what? Boiling point. Whether it is solid or liquid, whether the substance is solid or liquid, so far it's pure, it will melt or boil at its melting point and boiling point. If the substance is a solid, it will melt at its what? Melting point. If the substance is what? Liquid, it will do what? Boil at its what? Boiling point. That is for pure substance. You can also use that to check whether a substance is what? Pure. We call it test for what? Purity in chemistry. You can use this thing I said now to test whether a substance is pure or not. We call it test for what? Purity. The substance will boil, if it's a liquid, at its boiling point. If it's a solid, it will melt at its what? Melting point. But if the substance is impure, it will never melt at its melting point. It will never boil at its boiling point. In fact, if it is a liquid, the temperature at which it boils completely will be higher than its what? Boiling point. We call it boiling point elevation. We call it what? Boiling point what? Elevation. Okay, putting it down. And fast. I said that if a substance is pure, if it's solid, it will melt at its what? At its what? Melting point. If it is a liquid, it will boil at its what? Boiling point. But if the substance is impure, if it is a liquid, it will boil at a temperature above its what? Boiling point. If a liquid, it will boil at a temperature above its boiling point. We call it boiling point what? Elevation. Okay? Now, but if the substance is a solid, it will melt at a temperature below its melting point. So if a substance is impure and is a solid, it will melt at a temperature below its what? Melting point. If the substance is a solid and is impure, it will melt at a temperature below its what? Melting point. We call it melting point depression. So what it means is that if you get a solid and add other solid that is not the same substance and mix them, and you want to go and melt them, if the pure substance melt at a temperature maybe 500 degrees Celsius, for example, now, and you join with another substance, it will melt at temperature below that what? Melting point. Okay, now let me use the one you know, because you cook almost every day. Who cooks here? Raise your hand. Who cooks here at home? Everybody doesn't cook. Everybody can never cook at home. Who cooks here? Just raise your hand. You cook, right? You cook, right? You cook, right? Children, you cook, right? At home. You cook, right? You cook, right? You don't cook. Now listen. Try this. Get ordinary water. Water without impurity. Just water. Water alone. And get what? Get what? Water. Maybe water you packed. Oil. Ose. Pepper. Crayfish. The things you want to use to cook soup. Then check two of them. Water without anything boils faster at the same condition. Water without anything boils faster than water you packed all those things. True of us? True of us? Because of those things, they are what? Impurity. So the one with impurity will boil what? At a higher, it will take higher temperature to what? Boil. Does it make sense? Does it make sense? So that's what. So an impure substance, if it's a liquid, it will boil at a temperature higher than its what? Boiling point. But melts at temperature below its melting point. For what? Solids. For what? Solid. I think I've given 5 differences, right? Between pure and what? Remember, our aim, objective of this topic is that at the end, you should be able to do what? Distinguish between pure and impure substance. So if you come out tomorrow, someone asks you, please, can you talk to us on pure and impure substance? I believe we can scatter it from the definition, from the examples, from the differences. I believe we can do that. Yes. And I believe we can scatter it with this question on the board. Huh? Does it make sense? Good. Now, that's what's time? It's only late to please. I will stop here, please. We'll continue from the second subtopic in our next class, okay? Please, I want you to study ahead. Do this assignment, open your textbook, study these things, these topics. If possible, read all these topics I listed there. All these subtopics, read them. Then look at this question. You can answer this question if you read this thing I listed. Study them. Look at the objectives under each of the subtopics. Then you have to study. Make sure after reading the topic, come to that objective. Use them to form question. Use this objective to do what? Form question and ask yourself this question. If you can answer the question, that means you understood the what? Topic. Believe you me, if you enter any exam, you can answer it. Be it WAEC, be it JAM, you can scatter it and get A1. I'll get 2, 3 songs up here in JAM. All right. I believe any question? Any question? Any question? All right. Please, we'll stop here for today, and we continue on Tuesday. Monday we review these questions. I believe you give me a better response by then. If you have not copied these questions, please copy them. All right. Thank you very much. God bless you.